Hi everyone. So my name is Satyam Raha, and in this video I'll try to reverse a given number. Let's see the logic. So let's say I have a number 1, 2, 3. So think like a child. If a number is given to you, how you are going to reverse it? So somehow I need to take the last digit 3, then take the middle digit, then take the first digit, right? So it gets reversed. So somehow you can understand that I have to extract the digits from the number, right? Extract the digits from the number. So 1, 2, 3 was given. Now, obviously, you can see one thing, that the last digit is taken out first, isn't it? Followed by the second last digit, followed by the third last digit. That means the extraction is necessary. You know this extraction of digit is necessary, and the extraction of digit is required from the right hand side. Okay, so 3 should be extracted first so that it comes to the beginning, then the second last digit 2, right? So what you can understand from here is these two key points, that we need extraction and we need to do it from the right side. Now, can you think of some idea or some mathematical idea to extract 3 from 1 to 3? How do you think you can extract 3 mathematically if you have a number 1 to 3? What do you think? So, you see, one thing I can do is maybe I can divide 1 to 3 by 10. So, it will be 12, right? So, I'll write 120 here and 3 is the remainder, right? This is just most simple thinking, isn't it? From the basic mathematics, we can get the last digit of a number by simply dividing the number by 10, and I will take the remainder out of it, right? So once I get this 3, so I got the last digit. Next, I want 2. So how can I find 2? Now I have 1, 2, 3, and if I want to get 2, so it is not possible directly. But if you think it in some other way, maybe, see, I have already extracted 3, right? So 3 is not required anymore, isn't it? From 1 to 3, so from 1 to 3, I have already taken out 3. Then why should I consider 1 to 3 again? Because I only need to consider 1, 2 means 12, isn't it? Somehow I have to make 1, 2, 3 to 1, 2. So 1, 2, 3, somehow if I can convert it to 12, because 3 is already extracted and I do not require 3 now. So if I have only 12, so I can use the same logic again, right? I can divide 12 by 10 and I'll write this and I'll get 2. Okay. Somehow if I can convert 1 to 3 to 12, so I'll be able to extract 2 from 12 very easily by the same logic. Now, if somehow I can actually say convert, see, from 12, 2 is already extracted, right? So 1 should be left. So if I can convert somehow 12 to 1, what I can do is I can simply divide 1 by 10, and now what will be the result? It will be 0, right? Okay, so maybe a point will be there, or whatever it is, like 10, and 10, it will be 0 and I will get 1. Basic mathematics, right? I'll extract 1. So in this way, I can accumulate the 3 digits, 3 first, 2 second, and 1 third, isn't it? So it is possible. It is possible in this way. But I got the way, right? I got some way to extract the digits from the right hand side. But now what I want to do is I have to convert this. I have to convert 123 to 12, and then I have to convert 12 to 1, and this 1 will be converted to 0 at the end, isn't it? So this has to be done somehow. So can you think of some idea to convert 1, 2, 3 to 12? Can you think? How can I convert 1, 2, 3 to 12? Or 123 to 12? Can you think of something? It seems that if I divide 1, 2, 3 by, say, a number 10, so I'll get like 12 as the quotient and 3 as a digit. So we can take this quotient, it is 12. Again, in the same way, if I want to get 1 from 12, what I can do is I'll take 12 and I will simply like divide it by 10 in the same way what we did in the last page. So 10 into 1 is 10, and 2, we got the remainder here, and the quotient is 1, which we wanted from 12 to 1, right? So if you can use this logic, next I will have 1. So what I can do is I'll simply divide 1 by 10. It will be 0, it will be 0, and I'll have 1 as the remainder and 0 as the quotient. Yes, so we did it. Okay, so it is the entire game of remainders and quotient, as simple as that. Okay, I think you got the idea. I think you got the idea. For example, let's take another example. Let's say I have, say, 9764. How can I make it 4679? That is my question. So what I can do is I can simply divide 9764 by 10. What I will get is say 976, right? And I will get 9760 here, and 4 will be the remainder. So see, in the first stage we got the remainder, which basically is the last digit, and I can somehow make it to the beginning, and I'm left with 976, which can again be divided by 10. Okay, 976, and what will happen? I will be simply multiplying it by 97, and we can have 970 here. We'll have 6 here, so we got extracted 6, and this 6 can be brought here, and this 97 can be further divided by 10. Okay, and we can have 9, so it will be 90, it will be 7, so this 7 can again be propagated somehow here, so we'll get it here, and now this 9 can again be divided by 10, so we'll have 0, 0, and here 9, so this 9 can again be propagated here, so we got the reverse number 4679. Okay, so now can you think what is the next question? The next question is, we got the remainder and quotients, that is fine, but the next question is, how can you build this number? I know we are extracting it one by one, 4, 6, 7, 9. We got it. We extracted it individually. But how can it make you, how can you make it a number? If it were a string, say, we could simply concatenate it. That would have been very easy, right? So first 4 would be concatenated with the empty string, then with that 6 would be concatenated, then with that 7 would be concatenated, and then 9 would be concatenated. So that is very simple, right, when it comes to string. But when it comes to number, I need to make it 4679, an integer number. So how can you do it? Think of it again. So at first I'll get 4, right? So at the beginning I'll get something called 4. So fine, I got 4 at the beginning, that is fine. Next, when I got 6, how can I make it 46? That is the question. So I'll just write it in a new page. So 4679, this is the reverse number, right? The original number was 9764. We need 4, 6, 7, 9. Now you see, at first we'll get 4. So somehow I'm storing 4 in a variable. For example, let's say now next number is 6. I got 6. Now how will I make it look like 46? I have 4. I have 4. I have 6. How can I make it 46? It is again intuitive, right? Say 4 is stored in maybe int a equals to 4, and extracted number is 6. So say these two variables are there, for example. Okay, now my question is, how do I get 46 from these two numbers? What I can do is I can simply do a into 10 plus extracted, right? So it will be 4 into 10 plus 6, which is 46, isn't it? And store it in a. Say now a is 46. Okay, the updated a is 46, let's say. Now I have the next digit as 7, so extracted will be 7 now, isn't it? The next digit is 7 extracted. So now what can I do? I can simply use the same logic, this logic. So what can I do? I can simply write 46 into 10 plus 7, isn't it? So what will be the result? It will be 467. We got the partial reverse number, 467, right? So store it again in a, and the extracted digit updated will be 9. The next digit is 9. So what I can do is use the same formula again. So 467 into 10 plus 9, which is 4679. This is the result which we wanted. So in this way, we can reverse a given number. Okay, so the first thing which we require is, I'll just write it down. The first thing is remainder. Okay, when divided by 10. Next is quotient when divided by 10. And the third is the formula a into 10 plus, here what is a? A is basically the remainder, right? So let's write it r. So r into 10 plus the quotient. Okay, so these things are required basically. And till when this should be done? Say the number is 9764, right? So we are continuously dividing it by 10, isn't it, in every step? So we'll use a for loop. Obviously we'll use a for loop or a while loop, maybe whatever you want. Say a while loop till it gets to 0, till 9764. See, 9764 will be first converted to 976, then this will be converted to 97, this will be converted to 9, and at the end it will be converted to 0. So we'll run a loop till the original number becomes 0. Okay, so that is the basic of this program. That is all. Let's code it. Okay, so at first we need a number, right? So let's say I want scanner sc equals to new scanner system.in, right? Okay, the next I need is a number to be reversed. So let's say sc dot next int. Fine. Now we need to write a logic, right? So let's write the logic. So I said this number till it reaches 0. So number not equals to 0, I should run a loop, isn't it? So my intention is to make the number to 0. So in the middle, what we need to do is we need to first divide the number, isn't it? So let's divide it. Let's say, okay, let's first take two variables, int q comma r. Okay, so these are quotient and remainder. and let's take another one, say result. Okay, and let's keep initialize result to 0. Let's say at the beginning the result is 0. Okay, now the first task is to find the quotient, so I can simply do q equals to num divided by 10, right? Done. The next thing to be done is okay, if I divide the number, okay, I think I do not need a q. Okay, we need to update the number, right? We need to make the number to 0. So if I divide the number by 10 and store it in some another variable, how will number get updated? Isn't it? The number will not get updated. So we need to store it in num itself. We need to divide it by 10 and store in num itself. Then only num will get updated, isn't it? So before num gets updated, what we need to do is we need to get the remainder. So what we can do is num, there is a mod operator in Java. So mod 10, what does it mean? So number when divided by 10, the remainder will be returned by mod operator. Okay, so R will store the remainder of num divided by 10. Done. Now you see we got the remainder, right? So what we need to do now, we need to partially find the result, right? The partial sums, the partial digits, right? What is the formula? The formula was like this, right? So it was the quotient, isn't it? The quotient and multiplied by 10. Say the quotient is for example, say result. So result into 10 and then plus R, isn't it? So let's say the quotient is result. So if I multiply result by 10 and I do plus R, I'm doing the same thing which I have shown in the example, isn't it? Now you see this result is 0 at the beginning. See my example. See the example here. At the beginning, what was result? A equal to 4. I told you that A equal to 4. But what was before that? What was before this 4? Before this 4, if I say A was 0, then I could use the same formula of A into 10. So 0 into 10 plus R was 4, right? At the beginning, R was 4. The remainder was 4. So if I have used this formula, so I would have got A equals to 4. So that's how I got A equals to 4 at the beginning, isn't it? So this works fine if I initiate this A with 0. So in my program, I am actually using res in place of A, result in place of the variable A. Okay, nothing else. So let's continue. I hope you have no confusion. So result into 10 plus R. Okay, and what should I store this result to? I should store this result to res itself, because A needs to get updated, isn't it? A will store the partial sum or the partial result. Okay, so I wrote in my formula, right? A equals to A into 10 plus R. So that is the same thing. Res equal to res into 10 plus R. I could have used A also here, but okay, let me use A only, just to be consistent with what I have shown in the example. That's it. Okay, so now you see, after doing this, I am simply dividing the number by 10, and it will be done till the number reaches 0. So let's print the number here, always outside the loop. Why? Because inside the loop, if I print A, I will get a partial result, the partial reversed number, right? But I need the entire result, entire reversed number. So that can be found only after the number has reached 0. Okay, that is outside the loop. If I say give 1 2 3 4, see 4 3 2 1 is printed. If I say give 4 6 7 9, 9 7 6 4 is printed. So it's working, right? I hope you understood how the reversing logic actually works. It is very easy when it comes to string, because you simply need to concatenate it. But when it comes to number, it is a bit logical. You need to understand something. So always remember, if you want to reverse a number, because see, you will need this logic if you want to find the palindrome, right? Or maybe simply reversing a number, you need this logic. So first thing you need to do is extract the digits when it comes to reverse, right? And when you extract, the extraction should be done from the right side. Okay, and the next thing is you need to take the remainder when divided by 10. Okay, and you know the reason why. The next thing is you need to convert the number so that the last digit always is extracted or is removed. Okay, so I hope using these steps you understood, or you actually got an idea how the reverse works. Okay, so try to build some logic on your own. Maybe you do the Armstrong number. Okay, try it, because while doing the Armstrong number, also check for Armstrong number, you have to extract the digits in the same way. Okay, so see you in the next video. Thank you.